50% acid solution to obtain 54 liters of 20% acid. So you have 100% acid and 10% acid. You have 100% acid and 10% acid, right? Liters of solution and then liters of acid. Liters of solution, and then, oh, sorry, you could say sorry, the way they do it is they did it as, they do this like percent acid, like this, and then you have, let's call that A and B. So what does A represent?
Pure acid.
Liters of what?
Pure acid.
Pure acid. And what does B gonna represent? Liters of 10% acid solution. It's not a solution if it's 100%, but I'll write it twice. Okay, so you have A and B here. So you have A and B. To answer this question, you want to know how many liters of each solution there are, and then the total, right?
Is that a percent or of acid or percent?
Percent of acid in the solution. So you don't know the liters of solution. How much acid is in? What's the percentage for A? 100%, exactly. And what's it for B?
10.
10%. 10% is what in decimal? 0.10. And 100% is what? 1.00. So how many liters of acid are there in A liters of solution A?
1.
So no. A times 1. And how many liters of acid are there in the solution, the B solution? B times 0.10. Now, what's the total liters of solution that you end up with? 54. This is the total right here. Total is 54. What's the percent you want in the total? 20%, which is what in decimal?
0.2.
So you have 54 times what? 0.2, exactly. There are two equations we can make. What's one of the equations? What's the simplest equation? Yes.
A plus B equals 54.
Bingo. And what's the second equation? Yep.
X plus 0.1 y.
Yeah, or A and B. We called it A and B, but it could be X and Y. Yeah.
A
Yeah.
plus 0.1 b
Yep.
equals 0.2 times 54.
Which is, well, you can do it. So you can write it down. 0.2. All right. Yeah. Correct. Which is, you could write it as 10.8. Yes, absolutely. How many equations do you now have? 2. What's the easiest method for this one? Yeah, well, you isolate first in with which method? Substitution, yeah. So how about we say B is equal to 54 minus what? A. And what do we do now that we know what B is? We substitute it in right there. So what do we end up with? A plus 0.1, but instead of B, what are we going to write? 54 minus A, and then we're going to continue with the same thing, which is 10.8. One word for what we need to do next. Yeah, we're going to distribute to simplify. Yep, it's going to be 5.4 minus 0.1A equals 10.8. What do I subtract from both sides? So you have A minus 0.1A is equal to 5.4, because 10.8 minus 5.4 is 5.4. What is 1A minus 0.1A? Yeah. Yep. A equals 5.4. And what's nice? Guess what happens? A is equal to 5.4 over 0.9. What's that? 6. And you know that A plus B is what? 54. So B is going to be 48. So that's liters and liters. There you go. Now, do you expect there to be a lot more of the 10% solution? Yes. A is 100%, B is the 10%, right? And we're trying to make a 20%. Is 20% closer to 10 or 100? It's a lot closer to 10. So you expect there to be a lot more of the lower percentage.
I thought there's going to be like a lot more equations.
Oh, sorry, excuse me. No. How do we feel about this one now? If you set up that table, it's not that bad. You need to make sure to set up that table. Yeah. Actually set you up with? A table. Okay. So what's the relationship between distance, rate, and time?
Rate times time.
Distance equals rate times time. Exactly. Distance is rate times time. So what does time equal?
Rate divided by distance.
Distance divided by r. Distance divided by r. So do you see this table right here? Rate is, what is time again?
Oh, I have to do.
Good, that's awesome. Distance divided by r. So can someone tell me what goes right there?
100 divided by.
No. 150
That's what I meant.
divided by x. And what's the other one going to be? 400 divided by y. Okay, can someone give me the first equation? They travel, it says, what does it say? Covers in the same time. So what do we know about the two times? They're equal. So someone give me the first equation. Hannah.
150 over x equals 400 over y.
Correct.
And then to solve that, you have to
Well, we're not going to solve it yet because we have one equation and two variables. We need a second equation. We haven't used the relationship between the rates. What does it say the relationship is between the rates?
3 times. No, 20.
The rate of the plane, so y, is equal to what?
3x minus
20 parameters less than 3 times the rate of the train. So what is it going to be? 3x minus what? 20. So you know y is equal to 3x minus 20. Where do you plug that in? Right there. So what do you end up with? 150 over x is equal to 400 over what? 3x minus 20. Now what do you do? If you cross multiply this, you end up with 150 times what? Can you open that up for it, please? 3x minus 20. And what does that equal? What does that equal?
400x.
400x. One word for what's next. Yeah, 450x minus 3,000, right? 3,000 equals 400. And for some reason it's drawing down there now. That's nice. Equals 400. What do I subtract from both sides?
It's 3,000.
No.
Negative 3,000 equals negative what?
No,
Negative.
it's wrong.
If you subtract,
You could do it either way. You can do it either way. There's lots of... You're going to start your own rap label now? X equals negative 3,000 over negative 50. So you end up with negative 300 over negative 5. What's that going to be? 60. So we have 60 now. How do we get the other one? Yeah. So we get y is equal to 3 times 60 minus. So y is equal to 180 minus 20 is 160. Last thing you should do is state your answer. It'd be great when you did this if you didn't stop here. You could say car, or is it train? Sorry. Is it train?
Yeah, it's a train.
Train speed is what? 60 what?
60
Kilometers an hour, which is pretty slow. And what's the plane?
160. That's very slow.
160 kilometers an hour. Now you might suspect that that's slow, but those numbers could be true.
It's a
Here we go. So how many equations?
3.
3. How many variables? 3. Only method we're ever going to use on these is?
Elimination.
Well, actually, no. We could use elimination, so there's 2. Elimination or substitution. Or some combination of them. That's fine.
Yeah.
But your first goal, what's the happy land in the middle that we love to get back to? 2 by 2. We love getting to 2 by 2 land, and we do that by picking a variable and isolating it. Can someone give me a variable name and an equation number that you want to isolate? Gabby.
The top Z.
I think there's a better one out there.
Y, second one.
Why is that one better?
Because it's positive.
Positive. I like that one. Gabby, you can totally do it your way. I like doing it with this one because you get y is equal to negative 10 plus 4z plus x. Now, what do you do with these? With this, you take this and plug it in right there, and you take that and you plug it in right there. Do that for me right now and simplify the 2 equations. Do that for me right now and simplify both equations. Do not solve, just simplify the 2 equations. Okay, everybody, these are the 2 that I ended up with, and they were just verified by you 2. Oh, yep, you need the screen, sorry.
that's why I asked. I was like, are you just starting this now?
So right here, here's one of them, and here's the other one right there.
Wait, hold on.
There they are.